From the moment we are born, time defines us. The ticking of clocks, the rhythm of sunrise and sunset, the eternal heartbeat of the earth beneath our feet. We live believing that one day always equals 24 hours, unshakable, consistent, sacred. But what if that truth has quietly begun to crumble? Without our notice, something extraordinary has been happening. The earth, our home, our anchor in the void, is spinning faster than it used to. Not enough for us to feel the wind shift, not enough to make a tree bend or a wave rise differently, but just enough for the most precise machines ever built to detect a change. Our days are shrinking by the tiniest slivers of time imaginable. At first, scientists thought it was noise, a technical error, a blip in the data. But then it kept happening, over and over. Day after day, the Earth's rotation seemed to gain speed. It was as if the very rhythm of our planet was slipping out of tune, and no one could say why. Imagine this: the entire planet, all oceans, continents, and living beings, completing a full spin just a fraction faster than yesterday. You wouldn't notice it, not in your heartbeat or your breath. But the universe would. Satellites orbiting above, GPS systems guiding airplanes, atomic clocks syncing world economies. They all depend on Earth's precise rotation. When that rhythm changes, everything changes with it. For billions of years, Earth has danced with near-perfect balance, gravity, inertia, and cosmic geometry keeping it steady, predictable. But the universe doesn't promise stability, only change. The faster spin might be a whisper from the deep interior of our world, a pulse from its molten heart, or a sign that something vast and unseen is shifting across the planet's surface. And so, scientists began to look closer. They wanted to know, why is the Earth speeding up? What invisible hand has touched our world's motion? The answer, they hoped, lay in the most precise measure of all, time itself. To uncover the mystery, scientists turned to the one instrument capable of revealing the planet's deepest secrets: the atomic clock. Unlike ordinary timepieces, these clocks don't tick by gears or pendulums, but by the vibration of atoms, the fundamental rhythm of the universe itself. They are so precise that if one had been running since the dawn of the dinosaurs, it would only now be off by a single second. In laboratories and observatories across the world, these atomic clocks are linked through a global network, overseen by the International Earth Rotation and Reference Systems Service, IERs. Their mission: to keep humanity's time in sync with the rotation of the Earth. It's a delicate balance between the predictable flow of atomic time and the natural spin of our planet, which, as it turns out, is not predictable at all. For decades, Earth had been slowing down. The gravitational pull of the moon was gradually stretching the planet's rotation, lengthening the day by fractions of a second each century. But then suddenly, the trend reversed. In the early 2000s, scientists began to see something they never expected. The Earth was accelerating. The data was undeniable. At first, the difference was microscopic, a few microseconds shorter than expected. But by 2020, the acceleration became impossible to ignore. On June 29, 2022, the Earth completed one full spin, 1.59 milliseconds faster than the standard 24-hour day, the shortest day ever recorded since atomic timekeeping began. To most of us, that's nothing. But to physicists, it's seismic. A change that's small ripples through the fabric of measurement, requiring recalibration of satellite systems, space observatories, and even financial networks that rely on ultra-precise synchronization. The world's heartbeat had changed, and no one knew why. It was as if the planet's core had shifted gears. Something beneath our feet was altering the balance of mass, redistributing the Earth's internal forces, and quickening its spin ever so slightly. Was it the movement of molten iron in the core? The melting of polar ice changing the planet's shape? Or something else entirely? A natural cycle we were only now beginning to understand. Each theory opened a new door, but none offered the full picture. The only certainty was this: the Earth was no longer keeping perfect time, and humanity, for the first time, was watching its own planet rewrite the rules of its rotation. For centuries, humanity believed the Earth turned with unshakable precision, one complete spin, every 24 hours, forever. But nature has never been as predictable as we wish it to be. In truth, the Earth's rotation has always wavered, swayed, and stuttered, a cosmic rhythm shaped by forces far beyond our control. Every spin of our planet is influenced by countless invisible hands. The pull of the moon, dragging at the oceans through tides. The shifting of vast glaciers, redistributing mass across the crust. The slow, grinding breath of tectonic plates beneath our feet. Even powerful earthquakes can make the planet wobble like a spinning top. To an outside observer, Earth's dance might look graceful and smooth, but up close, it's full of imperfections. Our planet is not a perfect sphere. It's an uneven, restless body of rock and molten metal, forever adjusting its balance. Each movement, each tremor, alters the delicate timing of its rotation by tiny but measurable amounts. Over the eons, the moon's gravitational pull has been gradually slowing us down. Fossilized corals from hundreds of millions of years ago show that ancient Earth days once lasted only about 22 hours. The tides, crashing endlessly against the shores, have been transferring momentum away from our planet and out into space, pushing the moon slightly farther from us every year. But now, the opposite seems to be happening. After millennia of slowing down, our planet is spinning faster. It's a cosmic paradox that has left scientists stunned. The same natural forces that once stretched time may now be compressing it. The Earth, it seems, has never followed a steady beat, only a shifting symphony of motion. And while the reasons remain elusive, one thing is clear. This acceleration is not random. Something profound is at play, deep beneath the surface, hidden from view but powerful enough to change the tempo of the planet itself. It was an ordinary day, or so it seemed. June 29th, 2022. The world woke, worked, and slept as always. But in the realm of atomic precision, something remarkable happened. That day, the Earth completed its rotation in 159 milliseconds less than the usual 24 hours. The shortest day ever measured since we began keeping time. It's almost poetic. Billions of people living their lives unaware that the planet beneath them had just turned a little faster. Satellites above noticed. Atomic clocks noticed. But for the rest of us, time continued as usual, though it had subtly changed forever. For scientists, this was not just a curiosity, it was a clue. The Earth was no longer obeying the slow, predictable rhythm it had followed for centuries. This wasn't a glitch. It was a message, one written in milliseconds, telling us that our planet's rotation had entered a new phase. To measure such precision requires tools beyond imagination. Atomic clocks can detect changes smaller than a millionth of a second. When these instruments reported the anomaly, researchers at the IRs double-checked, then triple-checked. Yet every analysis confirmed the same truth. The Earth had indeed spun faster. What could cause a change like this? Some suggested that the redistribution of mass from melting glaciers might have altered the planet's shape, reducing drag and increasing rotational speed. Others pointed to seismic activity, or even changes in the liquid core, spinning at a slightly different rate than the crust above it. Each possibility only deepened the mystery. And behind every theory was a haunting question. If the planet can accelerate so subtly without warning, what else might it do that we haven't yet noticed? The shortest day ever recorded was not just a blip in time, it was a sign. A reminder that our world, though ancient and familiar, is still alive in ways we are only beginning to understand. The Earth's rhythm has changed, and scientists everywhere are racing to understand why. They've ruled out the obvious. It's not human activity, nor the pull of the moon, nor the drifting of continents alone. Something deeper, more complex, is influencing the speed of our planet's spin. One theory points to the melting of the polar ice caps. As ice turns to water, trillions of tons of mass shift from high latitudes toward the equator. This changes Earth's distribution of weight, just like an ice skater pulling their arms in to spin faster. The same physics applies to our planet, only on a colossal scale. Others suspect the atmosphere itself may play a role. Massive wind patterns and pressure systems circling the globe with unimaginable force can exchange angular momentum with the solid Earth beneath them. The jet streams, the trade winds, even deep ocean currents could be subtly pushing and pulling against the planet's crust. But there's another, even stranger suspect: the liquid metal core that spins far below us. Scientists now believe that fluctuations in the motion of this molten heart might cause measurable changes in how the entire Earth rotates. If the inner core shifts even slightly, the crust above responds, like gears in a hidden clock. And then there's the unknown. Phenomena we have yet to name. Earthquakes that alter the planet's moment of inertia. Volcanic activity beneath oceans. Magnetic field reversals that whisper of unseen energies moving through the planet's body. Each force contributes its note to the symphony of motion that defines the length of a day. It's both humbling and haunting. We've mapped the stars, peered across galaxies, and photographed black holes, yet the greatest mystery might still lie beneath our own feet. Beneath continents, beneath oceans, beyond the crust and mantle, lies a world of fire and pressure. The Earth's inner core, a sphere of solid iron the size of the moon, spins inside a sea of molten metal. For decades, scientists assumed it rotated at roughly the same speed as the rest of the planet. But in recent years, new evidence suggests something astonishing. The core might be spinning differently. Seismic waves, vibrations born from earthquakes, have revealed subtle discrepancies when passing through the deep Earth. In 2023, researchers from the University of Peking proposed that the inner core may have slowed down, stopped, or even reversed its direction relative to the mantle. A planetary heartbeat, changing rhythm. If true, the implications are staggering. The rotation of the core is linked to the generation of our magnetic field, the invisible shield that protects Earth from solar radiation. Any fluctuation in that inner motion could ripple outward, affecting the surface in ways we are only beginning to imagine. The connection between the core's spin and the Earth's overall rotation remains one of the great unsolved puzzles in geophysics. Some scientists think the core and mantle are locked in a gravitational dance, trading angular momentum over centuries, one speeding up while the other slows down, keeping the system in a delicate equilibrium. Imagine it: two massive spheres, one solid and one molten, spinning inside one another, sometimes in harmony, sometimes in opposition. When one shifts, the other must compensate. Perhaps that's what we're seeing now, the crust gaining speed as the core changes its rhythm below. No human eye will ever see this motion directly. It unfolds thousands of kilometers beneath us, beyond reach, beyond comprehension. Yet its effect is real, shaping our magnetic field, our rotation, even the length of a single day. The heart of our planet may be trying to tell us something, and perhaps for the first time we're beginning to listen. For most of us, a few milliseconds seem meaningless, but in a world built on precision, a world of satellites, atomic clocks, GPS signals, and internet networks, a fraction of a second can make everything fall out of sync. The Earth's acceleration is not just a curiosity of physics. It's a challenge to civilization's most fundamental systems. Every time the planet spins a little faster, atomic time, the perfect standard, begins to drift away from Earth's natural time. That drift may seem small, but its effects ripple outward. GPS satellites that guide planes and ships rely on perfect synchronization with the planet's rotation. A slight mismatch can send coordinates astray, like a cosmic game of telephone gone wrong. Banks, data centers, and telecommunication systems also live by atomic precision. Billions of global transactions happen each second, and all depend on the assumption that time is stable. But if the planet's rhythm shifts, that illusion begins to break. Engineers are forced to recalibrate servers, observatories must adjust calculations, and navigators must rewrite formulas. And then there's science itself. Astronomers measuring distant stars, physicists tracking particles, all must account for the fact that our world is no longer spinning quite as it used to. Every calculation built on the Earth's steady turn must now include a hidden variable: acceleration. It's a haunting reminder that even the constants we trust most, the length of a day, the ticking of a clock, the motion of our home, are temporary. The Earth does not move for us. It moves according to its own mysterious rhythm. Yet, amid the unease, there's wonder. To think that our planet, seemingly stable and ancient, still shifts and breathes like a living thing. That's both terrifying and beautiful. We are passengers on a spinning world whose pace we cannot control, only measure and marvel at. For decades, humanity has relied on a small adjustment to keep its clocks aligned with the spinning Earth, the leap second. Each time the planet's rotation slowed, an extra second was added to atomic time to catch up. A simple fix for a simple problem. But what happens when the Earth starts spinning faster? For the first time in history, scientists are facing the possibility of the opposite, a negative leap second. Instead of adding time, we would need to delete it. The world's clocks would skip forward by a second to stay in sync with the accelerating Earth. It sounds minor, but the implications are massive. Computer systems, financial markets, GPS satellites, and global communications all depend on precise, continuous timekeeping. A deleted second, a moment that never existed, could cause chaos in software and databases that simply aren't built to handle it. Some experts warn it could trigger unexpected errors, shutdowns, or even global network instability. International agencies like the IERs and the International Bureau of Weights and Measures are now debating whether to make this unprecedented move. No one wants to rewrite the definition of time. Yet, if the Earth continues to speed up, we may have no choice. Philosophically, it's even stranger. Humanity has always measured time by the motion of the heavens, the spin of the Earth, the orbit of the moon. But now, for the first time, we may have to remove time to keep up with our planet. A second that vanishes into nothing, erased to preserve our illusion of order. Think about that. Somewhere in the near future, a clock might skip from 23:59 to 58 directly to 00:00, a second that humanity never lived. One heartbeat of time, gone forever. And all because the Earth decided to move a little faster. If history tells us anything, it's that Earth is never still. Its oceans, its winds, its molten heart, all are in constant motion. The current acceleration may feel unique to us, but in the grand story of the planet, it might just be another chapter in an endless cycle of balance and change. Some scientists believe the spin will stabilize again, that what we're seeing is a short-term fluctuation, perhaps the natural rebound of the planet's crust after centuries of melting ice. The Earth, they say, is elastic. It breathes, expands, and contracts over millennia, responding to the slow forces of gravity, pressure, and heat. Others aren't so sure. They point to deeper, slower patterns, magnetic shifts, tectonic pulses, and oscillations in the core that take thousands of years to complete. To them, the acceleration could be part of a much larger transformation, one that we are only just beginning to measure. Either way, the implications reach far beyond physics. Our calendars, our clocks, even our definition of what a day means, all of it rests on a spinning world whose tempo we cannot control. If the rhythm of the Earth continues to change, humanity may one day have to redefine time itself. It's a strange thought. That time, which feels eternal and absolute, might one day need to be rewritten because our planet chose to turn faster. Yet that's the beauty and terror of science. It reminds us that even the constants we live by are not constant at all. And so, the future of Earth's rotation remains uncertain, a mystery unfolding beneath our feet. For now, all we can do is watch, measure, and wait as the seconds slip a little quicker through our hands. Maybe the question isn't whether the Earth is speeding up, but whether time is. Every heartbeat, every sunrise, every spin of the planet is part of a grand illusion, our attempt to measure the unmeasurable. Time isn't a thing we can touch. It's a shadow cast by motion, a human concept trying to keep pace with the universe. When we say the Earth is spinning faster, what we truly mean is that our measurement of time no longer matches nature's rhythm. Perhaps it never did. The more precisely we try to capture time, the more it slips away, revealing that it's not fixed. It's alive, flowing, stretching, folding. In a way, this acceleration is a cosmic reminder of our place in the universe. We live on a world that never stands still, not in its orbit, not in its spin, not in its evolution. The passage of time isn't written in numbers or clocks, but in motion itself. And maybe that's the most poetic truth of all. The Earth's speeding heartbeat is not a warning, but a whisper. That change is the only constant. That every second we live is already slipping into the past faster than we realize. So the next time you look at the clock, remember, time doesn't belong to us. It belongs to the planet beneath your feet, spinning through space, rewriting its rhythm with every passing day. The Earth is moving faster, time is running quicker, and maybe, just maybe, it always has been.